Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we're going to be doing Unit 3, Lesson 3. Our topic today is factor polynomials when a equals 1. And your objective for today is I will factor polynomials with a leading coefficient of 1. Also, don't forget to put your first and last name, the period, and the date in the upper right-hand corner of your paper, please. So when you submit your notes, I know that they're actually your notes and not someone else's. Let's just jump right in here. So the first thing we need to talk about to be able to understand what I mean when I say a leading coefficient of 1, or when I say that a is 1, you need to know what I'm talking about, right? So to understand that, we need to talk about the standard form of degree 2 polynomials. So a degree 2 polynomial has the highest exponent of 2. So for example, you might see x squared plus 2x plus 1. I know that this is a degree 2 polynomial because the highest exponent is 2. So this tells me that it's a degree 2 polynomial. You may have heard of the term quadratic in the past. A degree 2 polynomial is the same thing as a quadratic. So it's also known as quadratic. But in Algebra 2 and upper level math, we're going to call quadratics degree 2 polynomials. And you'll find out more about why we do that like next semester and beyond that. So the standard form of these degree 2 polynomials or quadratics look like ax squared plus bx plus c, where a is the coefficient, or what's being multiplied by x squared. B is the coefficient, or what's being multiplied by x, so the coefficient of x. And c is a constant. So c is some constant, there's no variable. So ax squared plus bx plus c is the standard form of a degree 2 polynomial. You always put the x squared term first, the x term in the middle, and the constant last. So if you look at x squared plus x minus 4, what are a, b, and c in this standard form of this polynomial? Well, remember, standard form is ax squared plus bx plus c. So a is whatever is being multiplied by x squared. Technically, there's a 1 out in front of x squared. So in this case, a would be 1. Then we have plus x. B is the coefficient of x. Well, what's technically the number out in front of this x here? A positive 1. And then c is our constant. So negative 4 doesn't have a variable attached to it. So it's a constant. It doesn't change. And our c value here is negative 4. So why don't you give it a shot in part B? For x squared minus x plus 10, tell me what a, b, and c are. Go for it. So a should be 1, b should be negative 1, and c should be 10. Now let's do part C. Part C has a little trick in it, and I'm going to see if you guys get it right. Part C is negative 2x squared plus 14x. What is our a, our b, and our c values? Go for it. So a should be negative 2, b is 14, and c is 0. Because there's technically a plus 0 here. But what is 14x plus 0? Well, it's just 14x. So that 0 drops out. All right, let's see if you can get part D. So 3x squared minus 1. Identify a, b, and c. Go for it. So I wonder if you got it right. The correct answer is a would be 3, b would be 0 this time, and c is negative 1. So this is technically 3x squared plus 0x minus 1. That -1 is still your constant, so that's C. The 3 is the coefficient of x squared, so A would be 3. And then B is 0 because what is 0 times x? Isn't 0 times x just 0? And then what would 0 minus 1 be? Well, then it would just be 3x squared minus 1. So hopefully you got that right. All right, so now let's talk about adding and subtracting polynomials. This is really just supposed to be a little review. I just added it into this lesson so we can review how to do this. And then I threw a few problems in for your homework as well. So example 2, part A, for 5x squared plus 3 plus 2x squared plus 3x cubed, to be able to add these, we need to get rid of the parentheses. Well, there's technically a +1 out in front of this set of parentheses. And if I distribute that +1, I get 1 times 5x squared, or just 5x squared, 1 times 3. Then in front of this parentheses, I technically have a +1. So I distribute that +1 and I get 2x squared plus 3x cubed. Then my final answer would be 3x cubed plus 7x squared plus 3. I'm going to combine my like terms. Now let's talk about subtracting two polynomials. So this is a little different than adding them, because this time we still have a +1 out in front of the first set of parentheses. So when I distribute that, it doesn't change anything in the parentheses. However, because I'm subtracting, I'm technically distributing a -1 this time. That's fun. So how many bells are there? Oh my goodness. So -1 times 3x is -3x. -1 times 4x squared is -4x squared. Let's combine our like terms. Let's see here. We got -7x squared, and then 4x minus 3x is 1x, or just x. Here we go. So why don't you go ahead and do the next two on your own. So part C, I want you to add 12x to the 4th plus 14 plus 3x squared plus -3x to the 4th minus 14x squared minus 8. Go ahead and press pause, plus press play when you're ready to check your answer against mine. So I got 9x to the 4th minus 11x squared plus 6. Now let's do subtraction. So take 3 minus 6x to the 5th minus 8x to the 4th minus -6x to the 5th minus 3x minus 4x to the 4th. Press pause and press play when you're ready to check your work. So as you can see, my final answer is -4x to the 4th plus 3x plus 3. All right, now let's get into some factoring. So sometimes when you factor, as you can see in example 3, part A, you've got two terms here, 8xy plus 4xy squared. So these two terms have some things in common. In fact, they have a few things in common. So if we identify the GCF of 8xy and 4xy squared, we're going to use that to help us factor. So in example 3, we are factoring using the greatest common factor. All right, so 8xy and 4xy squared. Well, 8xy can be broken down to 4 times 2 times x times y. 4 can be broken down to 2 times 2, so we have 2 times 2 times 2 times x times y. 4 is 2 times 2, x times, and then y squared is y times y. So just like we did in our previous lesson, we're going to circle what they have in common. So I see 2 2's, I see an x in common, and I see a y in common. So our GCF is 2 times 2, which is 4x, y. So we're going to factor out that GCF. So if I factor out, sorry, I'm going to zoom in so we can see my screen a little better here. If I factor out that GCF from both of those terms, I'm going to factor out 4xy, and I'm going to put it outside of the parentheses. So then what I have left in the parentheses is what's left in both of those terms. So as you can see, there's a 2 left in the 8xy. If I factor out a 4, an x, and a y, 2 would just be left. So I'm going to have 2. Then I'm going to have a positive. Well, if I factor out a 4, an x, and a y, all that's left in 4y squared is y. So I'm going to have plus y. So the factored form of 8xy plus 4xy squared is 4xy times 2 plus y. So step 3 then is to check to make sure that we're correct. So to check, you're just going to take the 4xy times 2 plus y and actually multiply or distribute. And then see if your answer matches what we originally started with. So 4xy times 2 is 8xy. Then 4xy times y would be 4x, and y times y is y squared. Well, does that match what we started with? Does 4xy match, or sorry, 8xy plus 4xy squared match what we started with? Yes, so we know that we're good to go. I'm gonna unbox those, that's not the final answer, but they match. So then this is the factored form of what we started with. So we circle that, that's our final answer. So now let's do part B together, and then I'll have you do part C on your own. So for part B, 14x squared y squared z plus 21x y squared z squared. So the first thing we're gonna do is we're gonna find the GCF of both of those terms. So 14 can get broken down to 2 times 7 times x times y times 7. 21xy squared z squared can get broken down to 7 times 3 times y times z times z. So I see that they have a 7 in common. Oh, it looks like I left the x out from 21x, sorry. That should have an x right there. Okay. They have an x in common. They have 2 y's in common, and they have a z in common. So we're gonna factor that out. So we're gonna put 7x y squared z out in front of the parentheses. Then what would be left? Well, what's left here is a 2 and an x, so 2x in the first term, plus, and I know it's plus because this is positive, by the way. What was left here? A 3 and a z, so 3z. And before we circle it, actually, we should check and make sure that we're right. Well, 7x y squared z times 2x plus 3z, we're going to distribute. And we get 7 times 2 would be 14. X times x is x squared, then y squared times z. Plus 7 times 3 is 21. X, y squared, and then z times z would be z squared. So we're good to go. We know we have found the correct factors. All right, so now you try one on your own. This thing has 4 terms though. So you're gonna wanna find a GCF that all 4 terms have, factor that GCF out, and then put what's left in those parentheses. Go ahead and give it a shot. Just give it your best try. And press pause, then press play when you're ready to check your work. Good luck. Before we go any further, I just realized that negative 160t cubed and negative 20t cubed are like terms. Negative 20t cubed was actually supposed to be negative 20t squared. So make sure you fix that. That should be negative 20t squared. All right, now go ahead and finish that. I'll see you in a second. All right, so you can see how I broke down all of the terms, all 4 of them. I circled in yellow what they had in common, which I realized was 2 times 2 times t, which is 4t squared, which you can see out in front of the parentheses here. And then what was left for each term went here. And I used the same signs in the original polynomial. So the first term is positive, the second term is positive, and then the last 2 terms are negative. So I got 4t squared times 9t cubed plus 10t squared minus 40t minus 5. And that totally checked out when I checked it below. As you can see, hopefully yours worked as well. Now let's get into the real lesson for today. So we've factored by finding the greatest common factor. And we've learned how to find the GCF. We've learned how to identify A, B, and C. Now let's do something where, let's learn how to factor where we don't have a greatest common factor. So if you look at x squared plus 5x plus 6, these terms don't have a GCF. Well, technically they do, but their GCF is 1. But this is still actually factorable. So we're going to learn how to factor today. And to factor this thing, we are going to factor by grouping. So we've got a degree 2 polynomial here. My highest exponent is 2. If we identified A, B, and C, we would see that A is 1, B is 5, and C is 6. All right, so this is how you factor by grouping when you don't have a GCF. So step 1 is to multiply A times C and make a factor tree for A times C. So we already identified that A is 1 and B is 5 and C is 6. So we're going to multiply A times C. So A times C is 1 times 6, which is 6. So we're going to make a factor tree for 6. A factor tree just lists all of the what times what is 6. So for example, 1 times 6 is 6, and 2 times 3 is 6. Then 3 times 2, but we already have that, and then 4 doesn't go in, 5 doesn't go in, 6 does, but we already have 1 times 6, so we're done. Step 2, find factors of A times C that add or subtract to make B. So factors of 6 that add or subtract to give us 5. Well, we could use 1 and 6 to get 5, and we can also use 2 and 3 to get 5. So what we're going to do is we're actually going to start with 2 and 3, because I know that if I add 2 and 3, I'll get this positive 5. I would have to subtract the 1 and 6, and that would involve a negative. But because all of these are positive, we have a positive 5x, we have a positive 6, I want to stick with positive numbers. So we're going to stick with positive 2 and 3. So find factors of A and C that add or subtract to make B. Those factors are 2 and 3. Now we're going to rewrite Bx using the factors of A, C. So using 2 and 3, we're going to rewrite Bx. So our Bx term is 5x. To rewrite that using 2 and 3, I would need a 2x and a 3x. Well, 2x plus 3x would give me 5x, right? Actually, I'm going to put this over here. Okay. Now we're going to rewrite the polynomial using the new terms for Bx. So we're going to rewrite x squared plus 5x plus 6 using x squared plus 2x plus 3x plus 6. So all I did was I replaced the 5x with 2x plus 3x. Now we're going to group pairs with parentheses and put a plus sign in between. So we're literally just going to take these two terms and put parentheses and these two terms and put parentheses. So we're going to have x squared plus 2x in parentheses plus, and then in parentheses 3x plus 6. Now we're going to factor out what each pair has in common. So what does x squared and 2x have in common? What's their GCF? Their GCF would be x, so we're going to factor out an x. Well, if I factor out an x from x squared, what would be left? An x. If I factor out an x from 2x, what would be left? A positive 2. Okay, what would the GCF of 3x and 6 be? Well, 3x and 6 both have a 3 in common. If I factor that out, I'm going to get x plus 2. And I can check that because x times x is x squared, x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. So if you ever get confused, you can always multiply it back in and just make sure that you're right. It's a good way to double check. So what you should notice is that What you should notice is that what's in the parentheses is the exact same. This set of parentheses matches this set of parentheses. So I know that I'm ready to factor. So when I write my factors, I'm going to put 2 sets of parentheses. In the first set of parentheses, I'm going to put x plus 2 because that's what matched in the parentheses here. Then in the other set of parentheses, we put what was left. So we have x and a positive 3. So we're going to have x plus 3. So we could check this to make sure that we're right. And I highly encourage you to always check your factors to make sure that you're right. I'm looking for some room to write this. I'm going to put it up here. So let's check. So is x plus 2 times x plus 3 x squared plus 5x plus 6? That's what we're trying to figure out. Well, let's multiply. X times x would be x squared. X times 3 would be 3x. 2 times x would be 2x. And 2 times 3 would be 6. Combine your like terms. So you get x squared plus 5x plus 6, which is what we started with. So we know that we're correct. So x plus 2 times x plus 3 are the factors of x squared plus 5x plus 6. All right. Let's do another one together. So in step 1, we need to use A and C. So off to the side, I'm just going to identify what my A, B, and C are. So my A would be 1, my B would be 6, and my C would be 8. So x squared plus 6x plus 8. So now we're going to multiply A times C. A times C, so 1 times 8 is 8. So now I make a factor tree for 8. 1 times 8 is 8, and 2 times 4. And then nothing else goes in 8. So step 2 is to pick the factors from that factor tree that add or subtract to get you B. So remember, B is 6. Do any of these factors, 1 and 8 or 2 and 4, add or subtract to get 6? Well, if I added 2 and 4, I would get 6, right? So I want to use the factors 2 and 4. Step 3 is to rewrite the bx term, or 6x, using 2 and 4. So if I do 2x plus 4x, I'm going to get 6x. Then step 4 is to rewrite the original polynomial using 2x and 4x instead of 6x. So we're going to have x squared plus 2x plus 4x plus 8. And now we have our 4 terms. So to factor by grouping, you always want 4 terms, which we have now. We started with 3, now we have 4. So now in step 5, you put your grouping symbols. You put your parentheses around the first 2 terms, your parentheses around the second 2 terms with a plus sign in the middle. So you're going to have x squared plus 2x in parentheses and 4x plus 8 in parentheses. Then you factor out what each pair has in common. So x squared plus 2x, what do they have in common? They both have an x. And then what would be left? Well, x times x would get me that x squared back, and x times 2 would get me that 2x back. Then what do 4x and 8 have in common? They have a 4. Well, 4 times x would get me 4x, and then 4 times 2 would get me 8. Well, hey, check it out. Our parentheses match. So you're going to write your 2 sets of parentheses. What they have in common goes in one, and what was left goes in the other one. So the x plus 2 goes here, and then the x plus 4 goes in the other one. And then we can multiply them just to make sure that we're right. So x plus 2 times x plus 4. I would get x times x is x squared. X times 4 is 4x. 2 times x is 2x. And then 2 times 4 is 8, combine like terms, and we're left with x squared plus 6x plus 8, which matches what we started with. So we know that this is, in fact, the factored form of x squared plus 6x plus 8. And there we go, we've just factored again. All right, now you try. So x squared plus 4x plus 3. So remember, step 1, multiply a times c, then make a factor tree for that number. Step 2, identify factors of a times c that will get you b, etc., etc. So just go through the steps and work your way through factoring this thing by grouping. Press pause and then press play when you're ready to check your work. Go for it. All right, so when you multiply a times c, you get 1 times 3, which is 3. The factors of 3 are simply 1 and 3. Well, 1 and 3 can add together to get 4. So I'm going to use 1x and 3x to get 4x. I rewrote my polynomial as x squared plus 1x plus 3x plus 3. Then I put my parentheses around the first two terms and the second two terms with a plus sign in between. And then I factored out an x from the first two terms. Then I factored out a 3 from the second two terms. I noticed that x plus 1 were in both sets of parentheses here. So that was my first factor. Then my second factor is x plus 3. What was left? So the factored form of x squared plus 4x plus 3 is x plus 1 times x plus 3. Remember, each of these are factors of x squared plus 4x plus 3. All right. Now, we're actually going to make a little change to part E because I realize we don't have any negatives anywhere in this. So we are going to change one of our signs. So we're actually going to change this to x squared minus 10x plus 16. Again, I'm going to know who's actually watching these videos because you had changed it. Okay, so x squared minus 10x plus 16. So even though b is negative, you don't need to worry about the negatives just yet. The same if like c was negative. If c is negative, you don't let that impact your factors. You just use the positive version of the number. So 1 times 16 would be 16. So then factors of 16 would be 1 and 16, 2 and 8, and 4 and 4. So what factors of 16 would add or subtract to get this negative 10x? Well, I know 2 and 8 would get me to 10, right? If we combine them. So how do we get negative 10x though? Well, what if we had a 2x and we had 8x? What if they were both negative? Is negative 2x minus 8x negative 10x? You betcha. So let's do this. So now we rewrite it using those two terms. So x squared minus 2x minus 8x plus 16. So for the next step, I need you to be super careful. Remember, you put the first two terms in parentheses, the second two terms in parentheses with a plus sign in between. So that means that x squared minus 2x goes here. That negative 8x goes in the parentheses. That negative sign stays with the 8x here. And then as you factor this, x squared plus 2x has an x in common. You need to factor that negative out with the 8. So factor the negative 8 out of both of those terms. Why don't you finish this problem without me and then compare your answer to mine when you're ready. Press pause and then press play when you're ready to check your work. So as you can see, I got x minus 2 after I factored out the x. Then I got x minus 2 when I factored out the negative 8, because negative 8 times x would be negative 8x. Negative 8 times negative 2 would be positive 16. And because I factored out the negative, both of these parentheses match. So that goes into one factor, and then what was left, the x and the negative 8, goes in the other factor. So our factored form is x minus 2 times x minus 8. And then we're actually going to add an extra example. We're going to add Example, what was that? E, we're gonna add example 3 part F. And I want you to factor x squared plus 3x minus 4 by factoring. So you're gonna factor it by, you're gonna factor it by grouping. So follow the exact same steps from above, multiply your A times your C, find factors of AC that add or subtract to get you B, create your 4 terms, and factor by grouping. Go ahead and give this a shot and see what you get, and then you can compare your work to mine when you're done. All right, so let's check this out. So when you take A times C, it's okay to ignore the negative in front of C at this step. So 1 times 4 would just be 4, and then factor 4. So 1 and 4 and 2 and 2. Then what factors of 1 and 4 of 4 would you add or subtract to get this 3 in the middle? Well, 1 and 4 will get me 3. So I'm going to rewrite my middle term using 1x and 4x. So what would the signs have to be to get a positive 3 when I add 1 and 4x? Well, if I take positive 4x and I subtract 1x, I'll get positive 3x. So now I have my 4 terms, and I can add my grouping symbols. So I'm going to have x squared minus x plus 4x minus 4. Now factor out what they have in common. Well, x squared and x have an x in common, so I'm left with x minus 1. 4x minus 4 have a 4 in common, and I'm left with x minus 1. Well, and I know that's right because x times x would be x squared, x times negative 1 is negative x, 4 times x is 4x, and 4 times negative 1 is negative 4. Well, thankfully, x minus 1 matches x minus 1, and what's left is x and 4. So my factors, what's in common, what's in the parentheses, that's the same, goes in one factor, so x minus 1. And then what's left, the x and the 4, go in the other one. So x plus 4. And those are my factors. X minus 1 times x plus 4 is the factored form of x squared plus 3x minus 4. And if you don't believe me, we could check it real quick. So x minus 1 times x plus 4. X times x is x squared. X times 4 is 4x. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. Combine your like terms. X squared plus 3x minus 4. And that matches what we started with. So there we go. All right, go ahead and get started on your extra practice, submit it, and let me know when you are done with your extra practice. Have a good day. I'll see you back in class.